Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. This show is brought to you by Auto Rescue Tools and Isaac Rodell. If you've been looking for a programming laptop, but you're not sure which one to buy or how to set it up, especially if you want to program multiple brands. You know, you've got some domestic vehicles, you've got European vehicles. Can the same software go on the same laptop? What size hard drive do I need? All those questions. Isaac's your guy. He can custom set up programming laptops that are ready to tackle any make or model. I got one of these laptops myself, and I can say that it is outstanding, and it really streamlines the process by having everything you need in one device. So if you're looking for something like that, I highly recommend checking out autorescuetools.com. You'll also find scan tools, diagnostic equipment, key cutting equipment, and much more. Check out the link in the show notes. I highly recommend it. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host again for this week. Thank you so much for joining me. You are stuck with just me this week. I got another little case study for you. Definitely want to sprinkle these in amongst the interviews that we have. This week, we are going to be talking about another Dodge, Jeep, Ram, Chrysler, Fiat, Stellantis product. This one's a Jeep, 2012 Jeep Liberty. Not a real exciting vehicle, but I wanted to talk about the problem that we came across with this one because I thought it was pretty interesting in the way that it presented itself, but there's a little bit of programming that goes into this, a little bit of diagnostics that goes into this. And although I wonder if I'll ever see this exact problem again, I do know a little bit more about how this system works. And if I see another one of these, I will be very well prepared. But you know, the fact of the matter is we see strange stuff like this all the time. And the key part of it isn't understanding and remembering how this exact Jeep setup works, but that you can sort through something like this and figure out how something works based on the information that you have at hand, your tooling, your past experience, and what you're seeing at the car with your test methods. So let's go through this. The issue that was presented to us on this 2012 Jeep Liberty is that the customer, or well, I should say the end user, the driver of the vehicle, brought the Jeep into a shop and they were going through it because it was stuck in four-wheel drive. And they determined that, hey, this thing is stuck in four-wheel drive because there is a configuration code in the drivetrain control module, or I believe it was also named the final drive unit control module. In this one, it had another name. To me, it's the drivetrain control module. That's the module that is in charge of the transfer case or in charge of four-wheel drive in a Jeep vehicle to me. And I'll be totally honest, there's so many names and acronyms that change over the years and the platforms and the different vehicles and then scan tool versus service information that sometimes I get the names of modules mixed up as far as what they're actually called on that vehicle, which, okay, that can be a problem if you're ordering something, but I just need a quick reference in my head. And this one's a drivetrain control module to me based on my experience with Jeep 4x4 Dodge vehicles. Anyways, it's the module in charge of the transfer case. They were saying that it had a configuration issue. Something was wrong, or that module coded for something being wrong in regards to the configuration of the rest of the vehicle, and that's why they determined that it was stuck in four-wheel drive. Now, they had done a couple things in attempts to correct this. Number one, that final drive unit or drivetrain control module had been replaced, And they had also replaced, I'm going to mix up names here, the TIPM, which I consider a TIPM. You could also say it's the BCM in one of these. I think the actual name was Front Integrated Power Module on this particular application, but to me it's a TIPM. It's a smart fuse box. It's the gateway module. It's the body control module of this era of Jeep vehicles. And they had replaced these in attempts to fix this, didn't fix the problem, and actually I think with the module replacement had built in some other issues. The drivetrain control module itself didn't change anything. They had the same code with both modules. The integrated power module, that created some issues because there was a used one in there. So we went back to original on that one. Anyways, they called us in to try to resolve this because they weren't having any luck. So we get involved, and Steve actually went out there first. We went through this, and we thought it might just be like a restore configuration. It's one of the features or functions on these Dodge, Ram, Jeep, Chrysler vehicles where the factory tool is the only thing that is going to effectively restore configuration to all of the modules on the vehicle. Now, there are Fiat architecture vehicles that have what's called a proxy learn, which you can do with aftermarket scan tools. And that pulls the configuration data that's in the body control module and then broadcasts out to every other module on the vehicle that is able to accept it. But you do have to have that correct configuration in the BCM to begin with. And that's kind of how these older pre-Fiat architecture vehicles were, is it wasn't necessarily, well, I shouldn't say it wasn't stored anywhere. It wasn't able to broadcast out to the rest of the vehicle through a module in the car. You had to do it through the Chrysler server, right? So all of the configuration for that particular vehicle is stored on the Chrysler server. And when you connect to it with the factory tool, YTech, you're going to access that Chrysler server based off of the VIN, and then it is going to push the configuration for all of the modules to align with what the sales codes for that particular VIN were, with a few clicks of a button and some internet connection. And again, I don't know of another tool that can do that in one swoop like that. Now, can you edit the configuration of individual modules with some aftermarket tooling? Yeah, definitely. And that happens. And sometimes that's really useful. Maybe you want to code out a particular component you've deleted. Maybe you want to add something. Maybe you want to change something. Alpha OBD is great for this. It's very user friendly. There's some other options out there too, but Alpha is the easiest way to go if you want to edit stuff. But of course, the problem remains if you go do that and then someone else, maybe they take the car to the dealer or somebody has YTech and they run that restore configuration, they'll just wipe out whatever you changed with the aftermarket edits. So something to keep in mind if you go down that road. Anyways, we're kind of thinking that this restore configuration might be the solution. We attempt that, doesn't work. Okay, now what do we have? We have a C2206 in that drivetrain control module that says straight out configuration error. That's what it's saying. And it's a hard fault, sets immediately. Well, I shouldn't say all the time. I will circle back to exactly when it's set, but when it was setting, it was a hard fault. C2206 configuration error, vehicle configuration mismatch, I believe is what it said. All right, so now we have to determine, is there something up with the drivetrain control module where it's not configured correctly for the vehicle, right? Do we have the wrong one or something like that? Is there another module on the vehicle that interacts with the 4x4 system that is wrong for the vehicle, not configured correctly? Or is there something else going on that is not very obvious based on the code? So to me, this code just indicates that, hey, somebody else is configured for a different option than what that module is configured for. And that's kind of how Chrysler works. It's coding, if you will. If you think of as built for Ford or just coding for any European vehicle, it's modules that have options built into them, right? It's got 5 different options, and the coding selects which option that car has. So if it's A, B, C, D, those are your 4 options. You picked B for this car, but really the rest of the car is A. There's your configuration error, okay? Or in this case, is it an all-wheel drive or is it a part-time 2 or 4-wheel drive, right? That would be an option configuration for this vehicle. So we have to figure out, is there another module with A and our drivetrain control module has B, and that's why they're conflicting. So we go through and we're looking at stuff, and Steve checked a lot of modules and went through different things, and we couldn't find anything that was wrong, right? We made sure we put the original parts back in. We went through the data as far as we could see, things that were obvious, and everything seemed to line up with the sales codes for that particular vehicle, right? And you can use resources to find the VIN number and see, okay, what came equipped on this vehicle. And for reference, this was a part-time 4-wheel drive. So you had a switch on the center console that indicated either 2-wheel drive, 4-wheel drive lock, or 4-wheel drive low. Those are your 3 options based on the position of the switch. Now again, shows 4-wheel drive on the dash. It's stuck in 4-wheel drive. It will not leave it. Okay, so after going through everything that we could, and I was kind of remoting in to help them a little bit, we couldn't find anything that was out of place programming wise, which is the reason, or the assumption that we went out there with. We didn't go into it a diagnostic necessarily. We were going to try programming and see if we could fix this, and didn't seem like that was going to be the case. Like I said, messed around a few different things, couldn't get it. And we weren't allotting for a diagnostic that day, so we decided, okay, let's read up on this. Let's come back with a plan. We'll diag it. We'll figure out what's wrong. So that's what we did. And I dug a little bit more into how the 4x4 system works, who's involved at what times, what inputs, what could be causing this, but also reading up on the code. And you need to look at the code number, which again, C2206, but then also look at the control module that it's setting in. Look at the code setting criteria for that particular module, because you can have some codes that will set, or you can have the actual code itself set in various modules, but each module has a different definition or at least a different criteria for setting that code. So we want to look at the module that's setting it and go through that flowchart, if you will. Sometimes it gives you some good information, and it did in this point. It really did, actually, hindsight, point to what I needed to look at amongst some other things, but it was in there. And basically what it was saying is making sure that the module's configured, that the front integrated power unit module is also configured correctly for the vehicle. So based on that, we can assume that it directly interacts with that module over a network, which is the case. But it also mentions both the transfer case part number and the 4x4 switch itself to make sure that these are the correct switch and transfer case combo. Again, because there's a all-wheel drive option, and then there is, or it's like a 4x4 auto option, I think it was, and then there's a 2-wheel drive option, which this one has. And again, looking up the sales codes of the vehicle on RepairLink shows that that is what this vehicle was equipped with, was 2-wheel drive, 4-wheel drive lock, and 4 low. We also looked at the transfer case type, and there were 2 different options. This had the right one, and it correlated to the correct 4x4 switch style. And this is in the DTC flowchart. So again, ton of information in there that's very relevant to what we're dealing with. But it kind of also helps us dial into like, okay, this code is for configuration error, but particularly for something to do with the switch and something to do with other modules on the network. So this episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. The link is in the show notes. That's about as much as I got out of the DTC information, but let's look at how this 4x4 system actually works and how the switch and the 4x4 drivetrain control module interact with one another. And that's where it gets us a little bit more information. If you look at the wiring diagram, or you could do system description operation, but honestly, if you can look at a diagram and start to understand the system just by that, it's a powerful tool. I've talked about that before on the podcast. It shouldn't be your only means of figuring out a system, but sometimes it is your only means of figuring out a system, is by deciphering the wiring diagram and looking at how it's set up to say, oh, okay, this is how this works. And that's what I did with this one. So we have our drivetrain control module that is on the CAN C bus, which is a powertrain CAN, high-speed CAN for Chrysler. You have your TIPM, or your front integrated power module, which is a gateway. It's on both networks. There is the CAN C, and there's also the interior CAN bus. And then you have your 4x4 switch, which is on no bus. It's not on the actual network, but it doesn't feed either the front integrated power module or the drivetrain control module, right? So this switch that interacts, that tells the drivetrain what option the driver is shooting for, is not connected to either of these modules. Instead, it's connected to the instrument cluster, or cabin compartment node, CCN. You'll see it abbreviated in the scan tool. It's wired up straight to the cluster. And then the cluster broadcasts that information over the interior CAN to the front integrated or power module, or the TIPM. At least that's how it's shown on the diagram. But what I need to know now is that the switch goes to the cluster, which then goes to the TIPM, which then goes to the drivetrain control module. So we've got a series of modules that pass along the information of the switch to the end module who has my problem. And again, based on my reading in the DTC, one of the big things that I need to look at is this switch in relation to the operation of the 4x4. So we have to figure out how this data is being transferred from one module to the next. And you might be asking, well, did you look at scan data up until this point? And we did. We looked in the drivetrain control for the status of the switch, and really all that we could see is that there was an error state for the switch as soon as this thing would code. And it is the one piece of information that we didn't quite understand, was that this code would only set in a certain circumstance. And I'll explain what I mean there as we move along, but this is what got me to that point, was looking at these modules. And we also took a look at, okay, are all these modules original to the vehicle? And with YTech, you can do that very easily with a vehicle scan report, looking at the original and the current VIN. And for the TIPM, for the cluster, for the drivetrain, they all matched. We had the original ones in there. Okay, well, that is good information. Now the question is, the configuration, which we should have already corrected, is the flash right, or are we missing another piece of information? And this is where I really started to look at the position of the switch reflected in each of the modules that were involved. And what I ended up finding by doing this, before I found my answer, is if you had the 4x4 switch in either 4-wheel lock or 4-low, the code would not set. This configuration code that would lead you to believe that there was a module configured incorrectly would not set unless you had the switch in the two-wheel drive position. And again, I double checked to make sure, okay, this is the correct switch and is the correct transfer case for the VIN number for this vehicle. It is. So when I have it in two-wheel drive, it should try to go into two-wheel drive, but instead it sets this code. Again, you put this in the 4x4 position, which, hey, your transfer case is still stuck in 4 all the time, but you put it in the 4x4 position, it will not code. Everybody's happy, which definitely confirms that I don't think we have a module that's the problem, right? A configuration setting in the module that's shared over the bus. Well, that doesn't seem to be the case, but we'll dig in a little bit further. Let's look at the positioning of this switch in all of the modules involved. Now, again, with the 4x4 module, it shows you either for lock or for low, but when it goes to the two-wheel drive, it just shows an invalid request or error state. It was something like that. It didn't show 2 and it didn't show anything else. It just showed like invalid data. Okay, now, again, that's the end user of that data. It goes through the TIPM first. And I went through the data PIDs and the TIPM, and I really didn't find anything useful as far as this position went. But I also wanted to look at the cluster and see, is there something up with the cluster? And as far as the configuration of the cluster goes, it should be configured when we do the restore config with YTech, and I think it was. But there aren't any real settings that you can change even if you wanted to in regards to 4x4, and you can check that with alpha OBD. There's nothing to really change there. But if you investigate into the data PIDs that are involved in the cluster, one of the CAN outputs shows you the position of this switch that is being broadcast out onto the network. It doesn't even show you the input. It just shows you the cluster's output that's going to the TIPM. And you could watch as you move the switch, even when the code's set. This was the helpful part, was looking at the cluster, that 4 low showed correctly, 4 lock showed correctly. But when you put it into the two-wheel drive position, it said all-wheel drive. That was the message that was being broadcast out onto the cluster. And that's when the configuration code set in the 4x4 module. Well, of course, the 4x4 module in this Jeep is not set up for all-wheel drive, or that might be the 4x4 Auto, I would imagine. But either way, all-wheel drive is not an option. So is the cluster wrong here? Is there something about this cluster? Was it replaced and somehow they changed the VIN to match? I wanted to investigate the switch before I make that call, because nothing about the cluster is saying, hey, I'm the wrong one for the car. But again, I look at the switch. It says two-wheel drive. Okay. Is it just a bad switch? Okay, well, can I prove that? How does the switch work? If we look at the diagram, again, helpful to understand how this works, the cluster just sends out a 5-volt reference, and it goes through a series of resistors in the switch. You have a ground on the other side in the cluster. And as you move the switch, the resistors move in a different series to create a different amount of resistance depending on where you have the switch, which creates a different amount of voltage that the cluster looks at and interprets the position of the switch. Okay? Following me there? We're just changing resistance. You could consider it a rheostat, but it only has 3 positions. But we're changing the resistance to change the voltage that the module interprets into a specific position of this switch. Okay, so let's pull the switch out and let's take a look. So I move it, and it doesn't go like open circuit or anything in this two-wheel drive. It has about 2.4 volts at this point. And I look through service information. It doesn't really give you any detailed info on what voltages are supposed to be in each position. But as curious as I am, I'm like, okay, well, I can create different voltages here. So I remove the switch and I put my variable resistor in line, and I watch the data PID in the cluster as I move my variable resistor, and I can watch the voltage too. And when I hit about 2 volts on the sensor circuit, which is about 800 ohms of resistance in my variable resistor, all of a sudden the broadcast message in the cluster said two-wheel drive, and if I cleared the code in the 4x4 module. It got rid of the code and it moved the transfer case into two-wheel drive immediately. I could hear it click. That was it. Now I could dial it back to about 2.4 and it said all-wheel drive. I kept going past 3 and it went to 4 lock, and you went higher and it went to 4 low. So I could essentially be the switch, but in between 4 lock and two-wheel drive, the voltage in there, which this switch was at about 1600, shows about 2.4 volts on that sensor circuit wire, which the cluster interprets as all-wheel drive. Now, here's the interesting thing. The cluster is set up, regardless of the configuration, to observe several different positions of the switch, some which may not even be equipped on that particular vehicle. They just built it in like, hey, if you see 2.4 volts, that's all-wheel drive. Doesn't matter what you're set up for. Again, there's not even really a specific configuration for the cluster in regards to the four-wheel drive, but the voltage that it gets determines what message it broadcasts out over the bus, which then gets broadcast from the TIPM to the all-wheel drive module, which then says, hey, I'm not set up for four-wheel drive. Somebody's configured wrong. I can't be getting this message. That doesn't belong on this car. So why did the switch have the wrong resistance? It looked like somebody had spilled some pop on it somewhere along the way since 2012. It was pretty, it looked like a worn-in Jeep that's seen some miles. And the fix was just replacing the switch. And you might say, well, okay, that's a pretty simple fix. And had you done some playing around with the switch and the code, maybe you could have figured that out. But I thought it was really interesting the way that this presented itself, right? A configuration code, a module saying somebody's not right for me because the message it was getting over the bus definitely wasn't right for it. But that was caused by a switch that just happened to have elevated resistance in a specific position and a module that was just happened to be able to interpret the wrong resistance as an option that vehicle wasn't configured for. Like, again, am I ever going to see this exact problem again? Probably not. Hey, if you're out there and you've seen this on these Jeeps, if this is a common problem, let me know. That could be interesting. I didn't see anything out there in the known knowledge sources about this that reference that. But that's the sort of stuff that we are up against when we are diagnosing vehicles, which makes it very challenging. And this is not a new vehicle by any means. This is a 2012. But we run into stuff like this every single day. And you get one-offs like this, especially doing what we're doing every single day. And so being able to sort through this, understand how the system works, maybe being able to bypass some components and understand what a specific component does and what it's looking for and how to maybe manipulate that and test it and see what happens. That's what's going to help get you through these challenges, these one-off problems that aren't in a known database out there. So I thought I'd share that one with you. Again, not so much about the specific vehicle and that you're going to run into it, but you might run into something very similar like that, and having the right mindset going into it, or at least thinking about this sort of stuff and thinking about how does a configuration code really get set? Who's looking for what and who's sending what? How does this system work? And then you can dive into it from there. So hopefully that's helpful information. Hopefully I didn't blab too much. Again, we'll try to get some more of these case studies out there. Tommy's going to be in Australia for a little while, so you might be stuck with me for just a while. You're just going to have to deal with it. But anyways, really appreciate everybody out there for listening and all the feedback on the show. Always keep that coming. Hey, if you want any podcast swag, we got t-shirts and sweatshirts. We will be happy to get some out to you. Shoot me a message on either Facebook or email. We'll get your shirt size, get that sent out to you. But other than that, let's get out there, start fixing the world one car at a time.